Hey team, it's Mr. Z, and today we're going to continue to practice writing quadratic equations. Let's dive on in. All right, these first four are all of the same form, and essentially it's all going to be, I give you a vertex, I need you to write the equation. Vertex form tends to write itself to be represented as f of x equals a times x minus h squared plus k. Now, the one with the vertex is going to be h comma k, and through the point is going to be x and f of x. Use these values to generate the a value. I'm going to plug in -3 for my y equals a times -1 minus, because it's part of the equation, 2 squared plus 4. Let's clean this up. -2 minus 1 is -3 squared plus 4. -3 squared is going to be 9. So I'm going to rewrite it as 9a plus 4. At this point, I need to continue to use inverses. I'm going to minus 4 from both sides, and I'm going to get -7 equals 9a. Then I'm going to divide each side by 9, leading me to -7 over 9 equals a, meaning that this guy is going to be concave now. I rewrite my equation with my f of x is equal to my 7 over 9 times x minus 2 times plus 4. Okay, number 2, number 3, number 4 are all practice of the same ability. Can you find your a value? And after your a value, plug it back in with your vertex. Let's keep doing a couple more practice. So, number 5, are these expressions equivalent? The first one is in standard form, and the second one I gotta just convert. I'm going to rewrite it as expanded form and then see where my journey takes me. So now let me multiply these guys out. It's going to result in x squared plus 4x plus 4 plus x plus 2 when I drop the parentheses, leading me to get x squared plus 5x plus 6, which they are the same. True. The expressions are equivalent. Not initially, but after we simplified it, both of them resemble the same form. In order to find what it looks like, I look at the highest degree. Since it is degree 2, it must be quadratic. All right, let's keep doing a couple more. For number 9, number 10, and number 11, you got to remember, what key information can I find out? So in number 9, it is in standard form. So what can I tell you about it? Well, I can tell you the y-axis and the concave up or down. So I'm going to give myself a sketch and then do my best to fill out the y-intercept, whether it's concave up or down. The next one is in factored form. So no vertex, no y-intercept, no axis of symmetry. Hold on. I will be able to tell you the x-intercept and if it's concave up or down. Now, vertex form, what you'll be able to tell me is the vertex, the axis of symmetry, whether or not it is concave up or concave down. Remember, with the axis of symmetry, it's always going to be x equals the h value. Okay. Let's zoom in and do a couple more. Notice on number 12, everything's on the left side. If I was doing number 13, before I even get started, I would subtract 24 from both sides, thus rewriting my equation as w squared minus 10 minus 24 equals 0. Notice how I took the time to write it in standard form. Now I would go ahead and factor this guy, and I would go ahead and write it out. It would be w squared negative 24 make that a little bigger. W squared negative 24. I ask myself what multiplies out to be equal to that. So let me factor. I know that w times w will result in w squared. I know negative 6 times 4 will be negative 24. When I multiply it though, notice how negative 6 and 4w almost make negative 10y. They were kind of the right numbers, but it's still not the same. So I'm going to make sure that I write out that I tested it, but I'm going to have to try another factor pair. So my next tool in my option is to think what other numbers go into 24, and I'm going to try negative 12 and 2, because I see that when I multiply them together, they equal negative 24, and when I add them, it will equal negative 10w. So this factors. Basically, it turns into w minus 12, and w, what kind of 2 is it? Positive 2, and it is equal to 0. Notice, using the zero product property, since it's equal to 0, since it's in standard form, and then I factored it, zero product property, I just ask myself, what is this going to be equal to 0, and when is this going to be equal to 0? Hence, I get w can be equal to 12 or negative 2. Now, if I needed to, since it's a quadratic equation, I could have used a quadratic formula. I will demonstrate with the first one. Okay, number 12, I can just let up a be equal to 3, b equal negative 1, c equals negative 10, and plug it into my quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So let me go ahead and substitute in some of my values. A is going to be 3. So I'm going to replace it to be 2 times 3. I'm going to also replace the a next to the 4 with a 3. Replace the c with a negative 10. And my final replacement is to substitute negative 1 with b. I put it in parentheses as a habit. Let me evaluate this. Negative 1 turns into positive 1, plus or minus square root of negative 1 squared is 1. Negative 4 times negative 10 is 40. 120 all over 6. X is going to be 1 plus or minus the square root of 121, which is 11, over 6, giving me two answers. When x is 12 over 6 and when x is negative 10 over 6. I simplify both of these, and I get my 2 answers. Hope this helped, team. That's it for today. Practice makes perfect. Get battle ready.